Was what?
I wrote X with the little mark, I don't know what it's called, and then
Yeah.
and then parentheses, I put 10, comma, 0.25 with power 2.
All right. Good. Those are parameters. That's the mean and the variance, right?
Mm-hmm.
Now what?
I did X is less than 9.6.
All right. And see, even though sometimes they'll actually show that in the problem, and if they don't, I always write it because it helps me understand what I'm doing. So the probability that x is less than 9.6. Basically, we're taking the information out of the paragraph, and everything we need to know, we're going to get where it's going to be down here. Does that make sense?
Yeah.
All right, so now what?
And then I also put the probability of X being greater than 10.4.
Right. So now what?
So after doing that, we convert it to z-scores.
So this is going to be 9.6 minus 10 divided by what?
0.25.
0.25, which is going to give you what?
0.054799.
Try that again.
Oh, negative 1.6. My bad. I was looking at the wrong one. I was looking at the
All right, good.
area. Yeah.
Keep checking. Negative 1.6. All right.
Mm-hmm.
Now what?
And then I got the probability. Well, you want me to do the second one
You
or?
can. However you want to do it.
Oh well, when I did when I put in the calculator, I got the probability of 0.054799 for the first one.
All right. So hang on. What are we changing this to? You said negative 1.6. And see here, if it's me, I'm going to rewrite my probability statement. Now it says the probability that z is less than what number?
Um, 0.054799.
No. What's my z score?
Oh wait, yeah, negative 1.6.
Okay. So what's happened is that I'm taking this statement and I'm rewriting it as a z score. And that's why I changed it from an x to a z. Does that make sense?
Yeah, I get that.
All right. Now, how did you find the probability?
I use a calculator.
All right. And just tell me in words what you did.
I went to 7,
Yeah.
and then I went to
What's the
uh,
lower limit?
negative 9 times 10 to the power 99.
All right. Now, here's the thing it's not a majorly big deal. But remember the tables. The tables don't work with negative numbers. They work with less than. All right. Here's our negative 1.6. All right.
Mm-hmm.
Now, what I would like you to be able to do is rewrite this so it's less than and a positive number. Now, it's already less than. So how can I find the same thing? This area right here is what I'm looking for. Okay?
Mm-hmm.
Now, do you see how this area over here is going to be exactly the same size?
Yeah.
Now, if I use symmetry and do 1.6, if I were to find the area below this and then subtract it from 1 minus the probability that z is less than 1.6. Now, don't get me wrong. I would like to see this. It's not necessarily like on the exam, if you're not understanding what I'm talking about, but I would like for you to be able to show me how to do this if the numbers are positive, have to be positive, and it goes down. Okay?
Mm-hmm.
Now, the thing is, if you do that, menu 7, and you do negative 9 times 10 to the 99, and then I put in 1.6. Now, don't get me wrong. I know what you did. You put in negative 1.6, right?
Mm-hmm.
But I'm putting in 1.6, and it's going to give me 0.9452, blah, blah, blah. Okay?
Mm-hmm.
But if I take 1 away, if I do 1 minus that, hang on, I got to go back. One minus that, I'm going to get my answer as being 0.054799. Now, is that what you got when you did this?
Yeah.
Exactly. Like I said, this is going to get you the right answer. The thing is, I'm not positive if you're going to lose a point because you don't show this. I think that they operate in the presumption that we're using the tables. Do you see what I'm talking about?
Yeah. That's what I did with another problem, like just to show my work, just because you're gonna have you.
Yeah, like I said, if here's what I would say. If you wrote this and then put this in the calculator and skipped this part and just wrote the answer, like just by adding this one line, I think it covers you. Do you see what I'm talking about?
Yeah.
You can even do it the way you did it, but I think that it might be helpful to you if you write it this way. Does that make sense?
Yeah.
All right. So what about the other side?
So on the other side, I did same thing, just with 10.4.
So that's going to be 0.25. What's that equal?
Positive 1.6.
1.6. And see, the thing is, again, I'm going to do the probability that z is greater than 1.6, right?
Mm-hmm.
So just looking over here, how could I figure this out? Well, first, do you see how these two areas are going to be exactly the same?
Mm-hmm.
So this area over here has got to also be the same thing. I don't even got to figure it out. Yes?
Yeah, I get that.
All right, now what?
So yeah, this was the part where I was confused. So after doing that, I didn't like. That's where I kind of got stuck.
All right, so here's the thing. Here's what they want us to find. They want us to find the expected number of bags of chips that do not need to be repackaged. So in my picture right here, where are chips getting repackaged?
In that middle section.
In the other section, when they're too big or when they're too small. This is when they get repackaged. This part here in the middle is when they don't get repackaged. Does that make sense?
Okay, yeah.
All right, now what I want to know is I want to know the area in the middle because that's when they don't get repackaged. So if both of those ends are each 0.05479, how can I figure out the middle?
Couldn't you like add the two
If I add them together or double them, what's this times 2?
1.09598.
1 point, is it 0.09?
Mm-hmm.
0.1, I mean?
Oh wait, it's 1 point.
1 point?
Mm-hmm. Oh wait, I forgot the 0.
Yeah, don't forget the 0.
All right, there you go. 0.109598.
All right, 1, 0. All right, now keep in mind, what you just found was the area of these two parts, the shaded in area, right?
Mm-hmm.
Now, how would I find the area in the middle?
You do 1 minus that?
Exactly. Because remember, the area under the entire curve is going to be 1. So if I do 1 minus these ends, that's going to give me the middle. What's the middle going to be?
.89042.
Okay, now, this is the probability, if you will, of the chips being in the middle. This is the probability that they're not repackaged. Now, if there are 500 bags, how many numbers would I expect to be in the middle?
Can you repeat that again?
So think of it this way. If I was rolling a die, what's the probability of getting a 6?
1/6.
All right. Now, if I throw the die 100 times, how many times would you expect me to get a 6? How would you figure it out? If I throw the die 100 times, how many times would you expect me to get a 6?
Don't you have to like do like 1/6 and raise to the power to 100, right?
No, I'm just going to multiply them together.
Just gonna do that.
So what's 1/6 times 100?
100 over 6.
It's going to be about 16.6. So it'll be 16 or 17. 17 throws. Okay? This is the way it works. If I know the probability of something happening, and it's going to happen a number of times, all I got to do is multiply the number of times my probability. Every time I pick up a bag, I ask myself the question, is it repackaged or not? Well, what's the probability of it being repackaged? 0.89042, right?
Yeah.
All I got to do is multiply that times 500. Now, what do you get when you do that?
Um, 445.21.
All right, now here's what we got. 445. 445.21. Okay? Now, in this case, do you see where it says the expected number of bags?
Yeah.
All right, so they don't want a decimal. They want a number of bags. So what would I make this? 445 or 446?
445.
Exactly. Okay? We wouldn't leave this a decimal. Because they're asking for a number of bags, well, there's not going to be part of a bag. Does that make sense?
Yeah.
All right. How are we doing with that?
Yeah, I felt good. That cleared up a lot of things.
All right, good. So then tell me about number 2. What do you think about number 2?
Oh, I feel pretty good about that.
All right. So what about number 3?
Yeah, this is where I got stuck. I got stuck here.
So let's take a look. What's going on here? It looks like a bunch of Chinese writing, or I don't, it looks like stereo instructions a little bit, right?
Yeah.
It doesn't seem like they gave us much information. Okay? So what we got to do, though, is we're going to do the same thing that we would do. What if I was trying to find this probability? What would I do with it?
You have to like convert it to a z-score.
Okay, so what would it look like if I converted it to a z-score?
You will do 5.
0.5.
Yeah,
That's
0.5.
0.5, right? Minus what?
Minus the mean, or 5.
Mu, which is the mean, right? Because remember, that is mean, right? And they're the same thing. Okay. Now, what would I divide by?
By the standard deviation.
Here's the trick, though. In a problem like this, where they give you some kind of formula like this, what you want to do is you want all the stuff to be the same. So in this case, you're using mu's. You with me?
Yeah, I get you.
So how could I express the standard deviation with a mu? In this case, how can I get this standard deviation by itself? What would I do? I want it to look like this. How can I make this look like that?
Can't you divide it by 5?
Exactly. So the standard deviation would equal the mean divided by 5. Do you agree with that?
Yeah.
And see, then I'm going to come over here and do that. All right?
Mm-hmm.
Now, what's 0.5 minus 1?
From negative 0.5.
So now I have negative 0.5 mu, you right?
Mm-hmm.
Divided by mu over 5. Okay? Now, here's what I would suggest. Do we divide by fractions?
No.
What do we do instead?
Keep change flip.
We're going to multiply it times its reciprocal, right?
Mm-hmm.
In this case, I'm going to change 0.5 into a fraction. What's 0.5 as a fraction?
1/2.
So this is going to be, and it's negative, right?
Mm-hmm.
So it's going to be negative 1 over 2. You with me?
Yeah.
And where would the mean go? Where would the mu go?
Would go. Wouldn't go on the bottom.
It's going to go on the top.
Okay.
Okay?
Mm-hmm.
Because think of it. If I write this, okay, negative 1/2 mu. All right, I guess I could have done that. But if it looked like this, do you see if I multiply them straight across, it would be negative 1 times mu over 2?
Yeah.
All right. Now, I'm not going to divide by this. I'm going to multiply by its reciprocal. So I multiply times 5. Oh, wait a minute. That isn't true, though. What did you say this was? What's 0.5 minus 1?
Or negative 0.5.
Oh, we got that. Okay, I've got it. I only saw the 1. All right, so now we're going to multiply by 5 over mu. Now, the first thing is, what happens to my mu's? What's mu divided by mu?
1.
Oh, yep. And it's gone, right?
Mm-hmm.
Okay, now, what's negative 1 times 5?
Negative 5.
And what's negative 5 divided by 2?
Negative 5/2.
Or what's it as a decimal?
2.5 or negative 2.5.
Negative 2.5, right?
Mm-hmm.
All right, now, let's keep in mind, what were we doing here? Finding what?
The z-score.
We just found it. This is our z-score. So now we're going to take this and rewrite this just like I did a minute ago. Now it's going to say the probability, not of x, but of z being greater than what number?
2.5 or negative 2.5.
Negative 2.5. All right? Now again, what I would want you to do is think of the picture. Negative 2.5 is going to be below the mean, right?
Right.
We're going to say roughly here. Okay? Now, z being greater than that is all of this area. Now, how could I also do this only being less than?
You could find the area of positive 2.5 below it, then
Exactly. Do you see if I go to positive 2.2, the area below that will be the exact same as the above negative 2.5?
yeah.
So what I'm going to do is write this. The probability of z being less than 2.5. Okay? Now, in your calculator, you can do either one of these. What'd you get? Do it for me. Tell me what you get.
I got 0.99379.
0.99379. Okay?
Mm-hmm.
So whenever you get a problem and they give you something like this, okay, some kind of formula, either involving mu or standard deviation, you're still going to find the z-score, but what you want to do is you want all the letters to be the same. I want this to be a mu, and this to be a mu, and this to be a mu. Now, we also could have done it another way, we could have done it as if we would have done standard deviations. For example, here, if I were to do this, what's mu? Mu is equal to 5 standard deviation, right?
Yeah.
So if I would have done this, 0.5 times 5, you with me on this? Do you see what I'm doing?
Yeah.
I'm taking this and putting it in place of that.
Mm-hmm.
All right, and then I'm going to subtract what mu is equal to, right?
Mm-hmm.
And then I'm going to divide by mu, or I'm sorry, what the standard deviation, sigma, okay?
Mm-hmm.
Now, what's half of 5?
2.5.
And so what I'm going to get is 2.5 sigma minus 5 sigma, all divided by sigma. Now, do you notice how there's all these sigmas here?
Mm-hmm.
What's this divided by sigma and this divided by sigma? What happens to them?
They'll cancel out.
And you'll notice how I have 2.5 minus 5. What's 2.5 minus 5?
Negative 5 halves or negative 2.5.
The same thing we got over here. Okay? If they give you some kind of formula, you can use it however you want. But when you're making your z-score, make sure that they're all the same letter. Over here, you notice how it's all sigmas. Over here, do you notice how it's all mu's? In this problem, they're typically going to cancel out the letters, but it's only going to work if you have all the same letter. Does that make sense?
Yeah, I think that was tripping me up because like I was doing all these
It is. So what will happen is sometimes people will do this top part, but then put the standard. Well, I don't know if you remember in class today. A couple of girls asked me, and what they had was 0.5 mu minus mu, but then they had over the standard deviation. And see, if you don't have all the same letter, then they're never going to cancel out. You can't get rid of it.
Yeah, I think that's what I had originally as well. That's why I was getting confused.
All right. So what about 4? What do you think about number 4?
Oh, yeah, that was the last I was working on. That was
That's the one you're working on?
Mm-hmm.
All right, so tell me what you got so far.
So I basically just like wrote the basic stuff.
Okay,
I just
so what's the basic stuff?
put x is greater than 12.
All right, so here. What do you mean x is greater than 12? X is greater than 12. Oh, the probability
Oh yeah.
that x is greater than 12 is equal to what?
0.04.
0.04. All right, that takes care of this, right?
Mm-hmm.
Now what?
I said that x is greater than 9, and the probability of that is 0.32.
Probability that x is greater than 9 is going to be 0.32. That takes care of that, right?
Mm-hmm.
Now what? What can I do?
You could go convert to z-scores.
All right, so what am I going to write?
You can write
Well, first, take a look at the problem. What are they asking me to find?
the mean and the standard deviation.
And then do you notice how they give me 2 pieces of information?
Mm-hmm.
All right. What you should be thinking in a situation like this is that it's probably going to be a system of equations. I'm probably going to write 2 equations, and then I'm going to have to cancel, I'm going to solve them simultaneously. So don't get me too concerned if the equations have 2 variables. So let's start with this one. 12 minus what?
The mean.
Divided by
The sigma.
equals.
Wait.
Here's where you got to think.
Yeah.
All right, now this we just made into a z-score. You with me on that?
Mm-hmm.
Now this is a probability. So what I've got to do is I've got to convert it into a z-score, because what I want to do is write an equation This is a z-score, and then I want to make it equal to another z-score. So take a look. If I drew this like this, all right, my number 12, how much of the area is above it?
0.04.
Is that very much?
No.
So my 12, we'll say, is like right here. And this area is 0.04. Are you with me on that?
Yeah.
All right. Now, what can I do to find the number if I have an area?
You could use your calculator.
I can, but what are the limitations?
It only gives you less than.
It only gives me, so here's the trick. I can find the z-score of this right here, but I need to know this area, not this area. So if the area above my number is 0.04, how much is going to be below my number?
0.96.
So it shouldn't be too hard to figure out. Do the inverse of 0.96. Tell me what you get.
I got 1.75.
Now, 1.75. And what we're going to do is we're going to write a couple more digits. 0, 6, 8. You don't got to write all of them, but you're not going to stop at 2 or 3. Okay?
Mm-hmm.
Now, let's go back over here and do the same thing. Now it's 9 minus mu over sigma. So I've just converted this into a z-score. Now I've got to convert this into a z-score. And once again, I need to take a look at it. How much of the area is above my number, number 9? How much of it's above it?
0.32.
Now, once again, I can find the z-score for this spot, but I need to know the number that's below it, not above it. So what's the number below it?
0.68.
So what's the z-score going to be?
0.46769.
Okay?
Mm-hmm.
Now, what do you think I'm going to do now?
You're going to multiply side by the standard deviation.
Yeah, here's what I'm going to do. 12 minus mu is equal to 1.75068 sigma. And what am I going to do in the same thing over here, right?
Mm-hmm.
Now what am I going to do?
We're going to multiply one of the equations by -1.
And it doesn't make a difference. I'm going to pick this one for no reason than the fact that it happens to be smaller than 12. But it doesn't make a difference, okay? So if I multiply this by -1, the entire thing, it's going to be -9 plus mu equals -0.46769 sigma. Does that make sense?
Yeah.
Now, when I add them up, what's 12 minus 9?
3.
And these cancel out. So 3 is going to equal this. Now, I can't do this. What's 1.75 blah, blah, blah minus 0.46 blah, blah, blah? It's going to be 1 point something.
Yeah, 1.28299.
1.28299, you said?
Mm-hmm.
And then sigma. How do I find sigma? How do I get standard deviation by itself?
You'll divide 3 by 1.282, blah, blah, blah.
So again, at this point, writing all that down isn't important. Go ahead and do 3 divided by this and tell me what the answer is.
Um, 2.3382.
All right, now that's this. That's the standard deviation. How are we going to find mean?
You just plug them in one of the equations that you
So
made.
here's what I'm going to do. I'm not going to write any of this stuff down. Do you see this is the standard deviation, right? And it's still in your calculator, right?
Right.
I'm going to go now and I'm going to plug it into this. So what do I have to multiply my 2.382 by?
Negative
So just
4.67.
push times negative 0.46769. Now what do I got to do to get the mean by itself?
You have to add 9.
So now just push plus 9. What's the mean?
$8.4885.
What?
I think I may have messed up. I did a little error, my bad.
Try it again. So again, like I said, the idea is to try to save you some work. Try to, there's no reason to write all this stuff down. Once we get to this point, we just need the answers, but they need to be right, okay? And so, take negative
my bad.
0.467, hang on, negative 0.46769 times 2.3382, and I get negative 1.09355, something like that. And then if I add 9, what do you get?
7.9064.
Right.
I just misclicked. I misclicked something.
Okay?
Yeah.
With me on that? But
Yeah.
what I'm saying is, don't go and write a bunch of stuff down that nobody's going to care about. I mean, I do want you to make sure that you get it correct. So if the only way you can get it correct is to write it down, then that's fine. But if you practice kind of using the numbers in your calculator and then just kind of going and getting it, it can save you some time and actually be a little more accurate because you're not copying things down, you're not rewriting. Every time you do something, you can make a mistake. Now, the other thing is, am I done? What they ask me to find?
The standard deviation, the mean.
At the end of every problem, you should always take a quick look at the problem and make sure you actually answered it.
Yeah.
We did, so we're done.
Yeah.
Okay, cool.
Yeah. Wait. So you found the z-score because you drew the graph right and how to say this yeah. So
Now,
like
what
the
you've got
way
to
you
be careful with is that sometimes when they do this, what if it was like this? The probability that x is greater than 12 is equal to 0.68. So again, if you draw a picture, how much of the graph is bigger than my number?
0.68.
So that means it's clearly below the mean, right?
Mm-hmm.
My 12 has to be somewhere over here because 0.68 is above it, right?
Right.
Now the thing is, what's on this side over here now?
0.4. No. Okay. Yeah. 0.32.
Okay. Now the thing is, I'm expecting this to be a negative number. Are you with me on that?
Yeah.
Now, the other thing is, if you would have put 0.68, it'll be the positive version of this number. That's what I'm saying is you've got to make sure by looking at this picture, I know this has got to be negative. So if what'll happen is sometimes people will accidentally put in the 0.68, which will give them this number. Okay?
Yeah.
It'll be the exact same number, only it'll be positive. You need to make sure that when you're doing this problem, that you know if your z-score should be positive or negative. In this case, you see how we could declare clearly they both needed to be positive. So if we would have gotten something different, we would have stopped and looked at it again.
Yeah, that makes sense.
You good?
Yeah, I get that.
All right. What do you think about number 5?
I haven't started, but yeah, let's do it.
Take a look at it. What do you think?
So I'm assuming that it has to do something with binomial you know what I mean? Binomial, yeah.
Okay. So what's 0.63?
The probability of success.
All right. And what's 20?
The sample.
Okay. So that means for number 5, A, N is equal to 20 and P is equal to 0.63, right?
Mm-hmm.
All right. Now, how do I find out the probability that exactly 15 have the internet connection?
You would do that. Oh, is it formula with the parentheses and stuff? Is
Yep.
that formula? Yeah.
Yep.
So you would do 20, choose 15.
Because I'm trying to find the probability that X is equal to 15, right?
Mm-hmm.
So then what goes next?
0.63.
Good. Now what power is it going to be?
15.
Right. Because remember, this is success. And this number is the number of successes, right?
Right.
So I need to have 0.63 15 times, right?
Mm-hmm.
Now I also need to have some failures because not all of them are successes. So what's the probability of failure?
Let me try to do mental math. Point is gonna be 0.37, right?
Right. Now, how many failures did we have? If we had 15 successes, we must have had
5 failures.
Okay?
Mm-hmm.
Now, you can write that. You need to write that down. You have to write that down. Now, how do you go to your calculator to get the calculator to figure it out for you?
You do 20, choose 15.
Menu 7.
Oh, menu 7?
4. Do you see where it says binomial PD?
Binomial PD. Oh, yeah, 4.
Right?
Mm-hmm.
Now, in this case, we're not looking for a list. We just need one. So push number 2, the variable. One variable.
Mm-hmm.
What's my number?
15.
And then what's my sample size?
20.
And then what's the probability of success?
0.63.
See, those are all the numbers I need. And press enter. What's the probability?
0.0508. Oh, and a 0.10508.
Right. Okay?
Mm-hmm.
So like I said, you could do this and you could enter all this in the calculator. But the thing is, or you could go to menu 7 and literally enter in 3 numbers and get this answer. Not that doing this would be all that tough, but again, like I said, the more things you do, the more chances that you're human, the more chances that you can make a mistake. So
Yeah.
what you want to do is, if you can find ways to do it with less times, less things, then it's going to be better. Even though this, like I said, both of them are pretty easy. All right. So what about part 2? How do I find that exactly 9 do not have the internet connection?
You can You can basically do the same thing, but you would for the failures you would put you would put 9. You would
In
I
this
know what
case,
you're
what am I
talking.
interested in?
Exactly 9 do not have internet connection.
But more specifically, not having an internet connection, right?
Right.
All right. So what happens is I have a new P. Because remember, the probability of success is the thing I'm interested in. It doesn't mean good or bad. In the first one, success was having an internet connection. What was the probability of that?
0.10508.
In this problem number 2, success is not having an internet connection because that's the thing I'm interested in.
Mm-hmm.
What's the probability of not having an internet connection?
0.37.
So all I'm going to do is the same kind of thing. There are still 20 trials. I want to find out if there are 9. But in this case, now the probability of success is not 0.63, but it's 0.37.
Yeah.
And I do exactly the same thing. Only I reverse the things, the numbers. You with me?
Yeah.
Now, for no good reason, on this problem and a couple of the other ones, some people have gotten the impression that we only use a binomial distribution if it says exactly a number or exactly a number. Keep in mind, remember we did binomial distributions. That is not always the case. How would I have done it if, say, we stick with part 2, okay? Say I do part 2, but instead of them saying what's the probability of it being exactly 9, what if it said it was the probability of being, let's say, less than 18?
You would do the same thing, but you do with you do it with the numbers 19 and 20, and then subtract that by 1.
Exactly. Because remember, when it's an inequality, so again, what if I did this less than, what if I did it and it was less than, say, 4? Then I would do the probability of it equaling 0, 1, 2, and 3, right?
Mm-hmm.
If it's to the end, close to the end, then like you described, I'm going to do 1 minus. So I don't want to give anyone the impression that because it's a binomial distribution, it's always going to be x equal a number. It just happened to be kind of coincident that that's what happened here. All right, we good here?
Yeah, that makes sense.
Now tell me about B. What are we doing now? What's happening?
They want us to find that the probability that no more than 390 homes of
What's the key words here?
Suitable approximation.
All right, now, okay, this is super important. These words are telling me now that what I'm going to do is take this binomial distribution, but what I'm going to do is I'm going to solve it using a normal distribution. Does that make sense?
Yeah.
All right, now, what do I want to find the probability of?
That more than 390 homes of a random sample of 600 homes in the town have internet connection.
Okay, so I want to find this, and what's my n?
600.
All right, now imagine if I was doing this by a binomial distribution, what would I have to do?
You
I have to
do
find the probability of x equaling what?
more than 390.
Which is 391, 392, 393, 394, 395. I would have to do that 210 times. Does that make sense?
Mm-hmm.
No one's ever going to expect you to do that. So, like I said, most of the time, they'll say these words, use a suitable approximation. However, if they didn't say that, but they had a large sample and it would never make sense to do it with a binomial distribution, as long as it meets the parameters of being n times p is greater than 5 and n times 1 minus p is greater than 5, then you would just go automatically do it. But I will tell you, most of the time, you'll see these words, a suitable approximation. All right, now if I'm going to use a normal distribution, what do I need to know?
You didn't include the 390, right?
I need what?
You include the 390.
Well, but what do I need for a normal distribution? What are the parameters?
Oh, the standard deviation has to be. I think is it there? No, there has to
What
be
are the
one.
two things I need to know? What goes
Oh,
here?
the mean and the
And
and
what
the
goes here?
yeah, the variance.
Okay? I need to know, if I'm going to do a normal distribution, I need to know the mean and I need to know the variance. How do I find the mean when I have a binomial distribution?
You do n times p, right?
And what's to find the probability that more than 300 of a random sample have the internet connection? Oh, okay. So then, what is my probability? What's my probability of success?
Point 63.
Because that part hasn't changed. Does that make sense?
Yeah.
All right. Now, the reason I say that is because you notice in part one, we went from 63 as probably a success, and then we switched it in part two. But here, we're still going to use that probability of being 0.63, right?
Mm-hmm.
All right. So now, P 0.63. How do I find the mean?
You do 0.63 times 600.
Okay. What's that going to be?
378.
And then how do I find the variance?
You do n times q, right?
I'm going to do n. I'm going to do n times p times q, or 1 minus p. All right?
Yeah.
So in this case, do you see how 378 is n times p?
Mm-hmm.
So I'm just going to do 378 times the probability of failure. What's probability of failure?
0.37.
What's 378 times 0.37?
139.86.
All right, now that's my variance, right?
Mm-hmm.
So now what am I going to do? Remember, I'm trying to figure this out.
So that's when I know you don't want to remember it like that, but like you either have to add point 0.5 or subtract 0.5.
Okay, so which one? So think about it. I want to do bigger than 390. Does it include the 390?
No,
So what am I going to use?
you have to add 0.5 in order to include.
So the number I'm going to use is 390.5. Are you with me on that?
Yeah.
So, and it's good. This is really important to remember. All right. I would suggest you write it right next to it so you don't forget, because you're so used to going over and grabbing this number. So let's go ahead and do it. 390.5 minus the mean. What's the mean?
378.
Divided by the square root of this. Right? What do you get when you do that?
I got 1.0569.
All right. Now remember, that's our z-score, right?
Mm-hmm.
So what I'm going to do is I'm going to go back and rewrite it. The probability that z is greater than 1.0569, right?
Right.
Now again, in my picture, 1.0569 is going to be somewhere over here. And this is what I'm finding, right?
Mm-hmm.
Now, what can I do to make it so it's less than?
You can, well, you can find the probability of less than 1.0561, and then you get that area and do 1 minus that.
Right. So what I would do is I would like you to see this 1 minus, and then do the probability of z less than 1.0569. All right. Now, in your calculator, you could do this if you want. Try it. Go to your calculator and push menu 7. All right, we're still going to do normal CD. The difference is, what's my lower boundary now?
Negative. What do you mean? Oh, no. It would be 1.0.
Let's try doing it this way. We'll do it both ways. You with me?
Yeah.
Okay, so put in 1.0569. You right?
Mm-hmm.
Now, what's the upper boundary?
It would be 9 times 10 to the power 99.
Exactly. I want a really big number. Okay? Now, the sigma, the standard deviation is still going to be 1 because we're dealing with z-scores, and the mean's going to be 0. So as we're talking about that. Now, what do you get?
I got 0.14527.
All right, I'm going to write that down. 0.14527. Okay? Now, let's do it the other way. Push menu 7. Number 2. Now let's do the lower, the second way. Okay? So now change it to negative 9 times 10 to the 99. Make my upper boundary 1.0569. Leave everything else the same. And then what do you get?
0.854721.
Now, do this for me. You see the stow button right above the 7?
Yeah.
Push stow, and then push the X button. It's right below the on button on the top, right-hand side. Do you see the X?
Yeah.
All right. Do you see how it says stored into X?
Yeah.
Now push menu and 1. All right. Now, if I do 1 minus X, what do you get?
0.14527.
Same thing, right?
I feel like I like this way better. It's more safe.
All right. So what I'm saying is, if you write, and you can do it either way you want, okay? But what I'm saying is, I would like you to write this down. But if you wanted to then put this in the calculator, you can save yourself a little bit of step and get the answer faster. However, if you do it this way, then when you put it in the calculator, it's always going to be the same. What's the lower boundary going to be?
Negative 9 times 10.
And see, that way you don't got to think too much about it. So whatever way is easier for you, you go ahead and do. Does that make sense?
Yeah.
All right, we good?
Yeah.
All right, take a look at number 6. What do you think about this one?
Doesn't seem too bad.
All right, so let's try it. It's normal distribution. So we're going to say ages are normally distributed with a mean of 15.2, and we don't know the standard deviation, right? They tell us that for a given standard deviation, that 30.5% of the children are less than 13.5. So how can I write that? The probability that A, the age, is less than 13.5 is equal to what?
30.5. Oh no, would it be 0? What would it be? It would be 30.5 divided by 100. 0.5 divided by 100. It will be 0.305.
Exactly. Okay? All right, now, what am I going to do?
Well, first thing you can do is try and convert it to a z-score. So,
So what am I going to write?
13.5 minus 15.2
Divided by what?
Sigma.
Good. Now, we just made this 13.5 a z-score. Now what we've got to do is we've got to make this a z-score. You with me?
Yeah.
Now notice how it says less than? All right. That means I can put in this number. What's going to happen is there is some number that has 0.305 below it. I want to know that z-score. So if it's giving it to me below already, do what's the inverse of 0.305?
I got negative 0.510.
Negative, say again?
0.51. 007.
Okay.
Mm-hmm.
So now what?
After doing that, you can find the standard deviation.
How do I do it?
You will multiply the standard deviation by both sides.
Right. Let's do this too. What's 13.5 minus 15.2?
Negative 1.7.
Okay, so it's now going to say negative 1.7 is equal to, and this is going to be negative 0.51007 sigma, right?
Mm-hmm.
Now what am I going to do?
You'll divide by the negative 0.51.
Right, so just push divide. Negative 0.51007. And what do you get?
$3.3328.
And again, I'm going at least this far, okay?
Mm-hmm.
And then I quick double check. That's the only thing they asked me to find, right?
Mm-hmm.
So I'm good to go. How we feeling about that?
Yeah, I felt good. That wasn't too bad.
So what about number 7?
Doesn't seem too bad either.
It's kind of the same problem, isn't it?
Mm-hmm.
Do you see how this has got words, but this has just got like this? But really, it's kind of the same thing, only what's different about it? I know the mean, and I know the variance. What don't I know?
The x value.
All right, so what's going to happen is that when I go and do this thing over here, this number is a number I won't know. But do you see how it's pretty much the same kind of thing?
Yeah.
All right, so let's try it. What am I going to put?
X minus 30.
Well, not X.
Oh, A.
Because remember, that's what, if that was a number, wouldn't that's what I would do, right?
Right.
So it's because remember, the thing is at the end, I want to find A. So I definitely want to have an A in my problem. A minus 30 over what?
The square root of 20.
All right, now we just converted this to a z-score. Now again, take a look at it. How much of the area is below my number?
0.9535.
And what's important is it's below my number, right?
Mm-hmm.
So now what number do I put in to find my z-score?
0.9535.
Do that. What do you get?
I got 1.6797.
Okay, good, right?
Mm-hmm.
Now what am I going to do to solve it?
You're going to multiply by the square root of 20.
All right, so again, I'm not going to do a lot of writing here. Now, in my calculator, it says 1.6979, blah, blah, blah. You with me on that?
Mm-hmm.
I'm going to push stow and then X. And then I'm going to push menu 1. And now I'm on the regular screen, right?
Mm-hmm.
So now I'm going to push X, which is 1.67978, right?
Mm-hmm.
And what am I going to multiply it by?
The square root of 20.
Square root of 20, okay? And I'm typing it in the calculator, right? Just like that, right?
Mm-hmm.
And then what do I get?
7.5122.
And now what am I going to do to get the A by itself?
You add 30.
I'm just going to push plus 30 right now. What is A?
37.5122.
Okay? You with me on that?
Yeah.
Once you get this, you don't need to write a bunch of stuff down. I mean, write as much as you need to make sure you get it right. But like I said, if you can get used to or good at keeping things in your calculator, then, once we have this written down, there's probably only they care about is what's the answer. Is that cool?
Wait, yeah. So I have a question. It's kind of dumb.
What's that?
But okay, so like how the px is less than 8. What does that mean? Like I know what that means, but like okay, so like how 30 is the mean,
so the
20.
probability that my random variable x being less than some number is going to be this much.
Oh, okay.
Does that make sense?
Yeah, that makes sense.
So the probability of my random variable being less than a number is going to have this probability. And in order to I need to know what that number is. But that's what that means.
Okay, yeah.
Cool?
Yeah, sounds good.
All right, what about number 8? Same thing, right?
Yeah.
Only this time it's going up. So let's try this. C minus
35
over
is 4.
Okay, now that's a z-score. So again, let's be careful. If I do a quick sketch, how much is above my number?
0.8770.
And see, remember, I never want to use an inverse when it's above. So how can I rewrite this so it says less than?
Can do 1.
What's less than C?
The 1 minus 0.8.
Yeah, what is it? What is that? What's 1 minus that?
0.123.
Okay, so now because you notice this is also true. If this is true, this has to be true. But this is now what I'm going to use my inverse for, right?
Right.
So put in the inverse of that. Tell me what you get.
I got negative 1.1601.
Right? And so now, how do I solve it? Push stow and x. Stow, x, menu 1. All right, now remember x is at negative 1.1601, right? So now type in x times 4. And what's that give you?
Negative 4.64.
And now how do I get the c by itself? What am I going to do?
You got 35.
Plus 35. What's the answer?
30.359.
Okay? So the thing is, like I said, when you're doing a situation like this, I want this to say less than. That'll tell me the probability to put in. Right?
Yeah.
All right. What about 9? What's going on here?
Oh yeah, I need to do one with these. Okay, so it's basically the same thing, yeah.
It is very similar. You're right. So let's think about this. Here's my picture. Right? There's the mean here in the middle. I don't know what the mean is. Oh, yeah, I do. No, what's the mean?
The mean is 20.
Okay. So clearly 23 is above my mean. Don't you agree?
Yeah.
All right. That's one line. That's this number. Now, I don't know what G is, but I do know what?
That
0.6776 is below it. Is that true? Now, do you think that's going to be below 20?
It should be below, right?
I would think it is. Okay? So let's go like this. Now, how much is between those two lines?
0.6776.
Okay? Now,
Mm-hmm.
this number right here, G, I don't know what it is. Okay?
Mm-hmm.
All right. So what can I do?
Well, you could convert the 23 to a z-square.
Okay, now, how is
Or
that going to help me? What am I going to do that for?
to well,
So keep in mind, I need to find this number. Are you with me?
mm-hmm.
How do I find a number using area?
Oh, you can use the inverse, right?
Well, what do I need to know then?
You need to know the letter. You need to know the z-square,
I
right?
need to
Well,
know,
no,
that's what I'm trying to find, right?
yeah.
I need to know what this area is down here, right?
Mm-hmm.
Okay, so let's think about this. How can we figure out that area that's below what I want to know?
You could um
So I do have 23, right?
right.
What if I found the area below 23? That would go all the way forever, right?
Mm-hmm.
Now, that's not this part, but how can I take that number and change it so it only has the part that I want?
We could subtract that from 0.6776.
Exactly. You with me on
Okay,
this?
yeah, that makes sense. Yeah, yeah,
All right. So here's what I'm saying. You're right. I want to find the z-score of 23.
yeah.
But the
Mm-hmm.
thing is, I want you to know why we want to find it. I
Yeah.
want to find the area below 23, and then I'm going to subtract 0.6776 from it. That'll tell me the area that's below my number. Are you with me?
Yeah, that makes
All
sense.
right, so let's try it. 23 minus what?
23 minus 20 divided by square root of 10
What's that z-score?
is 0.94868.
So 3 divided by square root of 10. Gosh, I'm screwing it up. Hang on. 3 divided by square root of 10 is 0.94. What'd you say it was?
868.
All right. Now, this is my z-score. I want to find out what's less than that. So go to your calculator and tell me what that's going to be.
I got 1.6321.
That's not what I got. Let me see. Maybe I may have screwed up. What'd you put in for the lower boundary?
Oh, I did area, my bad.
Because keep in mind, I'm finding a probability, right?
Mm-hmm.
Okay, now look at the screen. Do you see how 0.94868 kind of looks like a probability?
Mm-hmm.
And see, this is where you have to be careful. We're finding a probability. We took this number here and we changed it into a z-score. That's why it's important to write this down, because this is a z-score. So if I'm finding a probability, I have to put this in. Does that make sense?
Yeah.
Tell me what you get.
I got 0.82860.
All right, cool. Now keep in mind, that's everything below 23, right?
Mm-hmm.
So now what do I got to do to that number?
You got to subtract that from
So again, I'm going to push stow and X and then menu 1. And then what I'm going to do is I'm going to take x minus 0.6776. You with me?
Yeah.
And what do you get?
Negative 0.6766.
I got this.
I think
Did I screw something up?
No, I think I screwed something up
Let me
because that
try.
one.
Nope, I
Oh
screwed.
yeah,
Nope.
yeah, I screwed up.
All right. You get me on this? You see what's
Yeah.
going on here?
Mm-hmm.
All right, now, what are we looking at here?
That's the probability, right?
Where? It's this area right here, right?
Yeah.
We just found the area or the probability below my number. Okay?
Yeah.
Now, how do I find G?
So that's when you would use inverse normal, right?
Exactly, because see, now I'm putting in an area. What's the area?
0.1510083.
Okay? Now, what's my Z-score?
Negative 1.032.
All right. Now, keep in mind, we just found the Z-score. We got to take this G and make it into a Z-score. So what's that going to look like?
That's going to
G minus what?
minus 20
Divided by?
the square root of 10. Yeah.
So now how do I get the G by itself?
Multiply the square root of 10 and
Okay.
that.
What do you get for G?
I got I got 16.736.
Okay. So you can see why this is on this paper near these problems. Do you see how this is similar? But there is more stuff we've got to do here.
Yeah.
But on the other hand, it really isn't anything more than we've done before. It just takes a little bit of work to find this area that's below my number. Keep in mind, if I know the area below my number, I can find the number.
Yeah.
So tell me about number 10.
Oh, so in this case, yeah, we're gonna give us all the information.
So in this case, 26 is here, 28 is here. They're both above, right?
All right.
And I want to find the area between them. How do I find the area between them?
You gotta find the area below 26.
So find the area below what?
26.
Start with this one. Find the area below 28. And then what?
The area below 26.
And then subtract, right?
Mm-hmm.
So here's what I'm going to write it. Find the area of x being less than 28, then subtract the probability that x is less than 26. Whoops, didn't put less than 26. Okay? Now, by writing this literally tells me what I've got to do now. Okay?
Mm-hmm.
So let's do them one at a time. How do I find the area below 28?
You have to convert to a z-score, right?
Good. 28 minus what?
25.
Divided by?
The square root of 6.
Okay, so what's 28 minus 25?
That would be 1.2247.
All right, now keep in mind, I'm going to change this again. The probability that z is less than 1.2247, right?
Mm-hmm.
All right, now before we do that, let's go ahead and do the other one.
So the z-score for that one is 0.4082.
Okay? So now what I'm going to do is I'm going to do minus the probability that z is less than 0.4082, right?
Mm-hmm.
All right, so now find this one. What's the probability of being less than that number?
Oh, yeah. 0.8896 for the first one, and then for the other one, and for the second one, 0.6584.
See, now I got to do a subtraction. What do you get?
And um, 0.2312.
Okay, you with me?
Yeah. Yeah.
So whenever you've got an area between two numbers, you find the area below the bigger one and then subtract the area below the smaller one. Right?
Yeah, sounds good.
All right, tell me about this graph. The mean is 80 and the standard deviation is 5. All right, so let's try this. We're going to write two of them, right, for part one. So let's see. We're going to say E is economics. E, normal distribution. The mean is what?
80.
And what's the variance?
Um,
Or I'm sorry,
square
the standard deviation.
is 5.
So we're going to say 5 squared, right?
Yeah.
And then business, what's its mean?
70.
And what's its variance?
2.5 squared.
All right, so 2.5 and again squared. All right, so let's start with this one. If I'm drawing a sketch of this, this is the mean, right?
All right.
What's the mean?
80.
So I put an 80 here. All right, now remember, most of the graph is going to be within 3 standard deviations. What's a standard deviation?
5.
So I'm going to do 1, 2, 3. Are you with me on that?
Yeah.
And this number is going to be 85, 90, 95, right?
Mm-hmm.
And then I'm going to do 1, 2, 3. And they should be roughly equally spaced, but it won't have to be perfect, okay? So
Mhm.
then what's this number going to be? 5 below 80 is,
75,
and then 5 below 75 is,
70,
and then 5 below 70 is.
65.
All right, so keep in mind, like I said, if we had a Z, if we made this into Z scores, this middle number would be 0, and then it would go 1, 2, 3. And then it would go down, -1, -2, but -3. But we can still do this. We know it goes up a standard deviation, right? And we know that most of the graph is within 3 standard deviations of the mean. So there's my one picture, right? Now, how is this other one going to be different?
It would have the mean of 70.
All
Or,
right, so what's going to happen is its peak is going to be right here, right?
right. Mm-hmm.
All right, now what else is going to be different about it?
It's going to have a standard deviation of 2.5.
So how's that going to affect the way the graph looks?
It's going to be more, wouldn't it be more compressed?
And
Right?
it's going to be, but keep in mind, they both have an area of 1.
Right.
So what's going to happen is it's going to be taller and skinnier. Does that make sense?
Yeah.
The standard deviation is smaller, so it's not going to be as spread out. Okay?
Mm-hmm.
So what I'm going to do is, I'll do it like this. I'm going to say that the other graph is going to go up this high. Okay?
Mm-hmm.
Now keep in mind, 3 standard deviations is going to be most of the graph. So what's 3 times 2.5? 7.5, is that right?
So, yeah, 7.5.
All right, so then what's going to happen is, if I go, it's most of the graph is going to happen by here, because that's 7.5 away. So it's going to look like this. Wow. And again, this, I'm drawing sideways, so and then again, 7.5. Most of it is going to be here. Now, don't get all hung up about it. What they're looking for in a question like this is that the one graph has got a different mean, and it's going to be taller and skinnier than the other one. Does that make sense?
Yeah.
When they say sketch, they probably aren't even expecting you to put numbers on here. Okay?
Mm-hmm.
So as long as you put 2 graphs and the one was below the other one, and then it went higher and was skinnier, that's what they're looking for. Does that make sense?
Yeah. Wait, so the standard deviation is like the number between the number. I don't,
So just remember, most of the graph is going to happen within 3 standard deviations of the mean.
okay.
So that's why we went 85, 90, 95. And you see how now it's getting really low? It's towards the ends.
Yeah.
Most of the graph is going to be within 3 standard deviations. Most of the graph is going to happen within 7.5 of the mean. Cool?
Yeah.
All right, so in the blank below, describe the differences and the similarities. All right, so what's the difference about them?
The one with the mean with A is more spread out.
All right, so let's say the economics one is 80, and we're going to say that the business one, so the business one is taller,
Mm-hmm.
and more narrow, right?
Right.
It is also got a lower mean, right?
Mm-hmm.
Right. Now, what's similar about them?
They both have the area of 1.
Bell-shaped curve,
Oh, yeah.
both curves have an area of 1.
Yeah.
Okay?
Yeah.
And see, then it says here, if you scored a 75 in both subjects, what percent of the students got better results? How do we figure that out? If I got a 75 in business, do you see how much is going to be above me?
Not a lot.
Right? Okay, so, but we can figure it out, right? Because it would be the probability that the score, or X, is greater than 75. And we do 75 minus 70 over square root of 2.5. And then we'd find that number, right? Let's see, 75 minus 70, that's 5, divided by square root, oh, that's 5 too. So it's going to be 1, right?
Right.
Okay, so the probability that X is greater than 1, well, that's the same thing as saying 1 minus the probability that X is less than 1. But anyway, or I'm sorry, Z, right? Because we found the Z score. All right, so then we can figure that out, and that would be the probability above, right? Now, how would I do it for the pink one?
You would
Same
do
thing, right?
Yeah.
70. So here, it's going to be a bigger number, isn't it? Because 75 is below the mean. This is going to be 75 minus 80 over standard deviation is what?
Square root of 5.
Square root of 5.
Oh, wait, no, that would be, yeah, just 5, yeah.
Right? So that, again, is going to be -1, right? So this is the probability that Z is greater than -1, which is going to equal the probability of Z being less than 1. Are you with me in that? So anyway, we could figure both of them out, but you can see here already there's going to be a whole lot more people that are going to be above the mean of 75 in the pink graph than on the green graph. On the green graph, 75 is on the high end. There's not that many people that were above me. On the pink graph, more than half of the class is above me.
Wait, so how do you know that so if it has like a smaller standard deviation, then it'll be more,
If it's
taller?
got a smaller standard deviation, then it's going to be taller and skinnier, less spread out. If it's got a bigger standard deviation, it'll be lower but more spread out. Because keep in mind, like you said, both of these curves have an area of 1. So if they both have an area of 1, I can't just make this the same height and make it skinnier. It won't have the same area. Does that make sense?
Yeah.
So the only way to make it skinnier and have the same area is if it's also taller.
Yeah.
And again, like I said, if there was a question like this, it wouldn't have to be exact. This is what they're going for. They want you to show that the one is more spread out, that the other one is taller and skinnier. Are we good?
Yeah.
Are there any more on here? Oh, this is like we did in class. Do you know how to do this one?
Was it from what we did from last class?
Yeah. Do you remember the other one we did was 1 standard deviation, right?
Okay, I wasn't here from last class.
So let's talk about this one.
Alright.
A normal distribution has a mean of mu. Okay, that's in the middle.
Mm-hmm.
All right. Now I want to find how, if I have 18 observations, what would I expect if the numbers I'm looking at are 3 standard deviations above the mean and 3 standard deviations below the mean? Do you see how that's what this means? The mean plus 3 standard deviations. So 1, 2, 3. And then minus 3 standard deviations. 1, 2, 3. What they want to know is what's this area right here? How could I figure it out?
Well, we first have to find the area of the two things that they give you, and add that. You do
So
1 minus
first,
that.
because we're talking about standard deviations, if this was a 0, wouldn't this be 1, 2, 3?
Yeah.
And wouldn't this be 1, 2, 3?
Mm-hmm.
This is lined up just like a z-score. What's the upper z-score?
U plus 3.
But what would it be if it was the standard deviation of 1?
Would it be 3?
And what would it be below?
-3.
So what basically is happening is that this is telling me what the z-scores are. What are the z-scores? 3 and 3. What if it was the same problem, only it says find the probability between mu minus standard deviation and mu plus a standard deviation. In this case, how many standard deviations am I above the mean?
1.
How many standard deviations am I below the mean?
1.
This is my z-score. This is my z-score. What if I said 2?
Be 2 below and 2 above.
Are you with me on that?
Yeah.
So this is my z-score. In this problem, what I need to do is find the area between these two. So I need to find the probability that z is less than 3. That gives me this, right?
Mm-hmm.
And then I need to subtract the probability that z is less than -3. You with me?
Yeah.
All right, so let's try this. Now, there's another approach you could do. Do you see how this is going to be symmetrical?
Yeah.
Do you see how these two areas are going to be identical?
Mm-hmm.
If I found one of these areas and doubled it, I could take it away from one, and what will be left over will be the middle. What do you want to do?
Z is less than -3. So just double it.
Okay, so I'm going to go with that here. So again, I'd rather you think about it as being less than a positive number, right?
Mm-hmm.
So find this area right here. The probability of z being less than 3. What if I did 1 minus the probability that z was less than 3? What would that give me?
The same.
Okay.
The same.
What is that? What's the probability that z is less than 3?
.9986.
Okay. Now do 1 1 minus that.
Ooh, I got
All right, now
1.349.
keep in mind, it's pretty small, right?
Mm-hmm.
But keep in mind, we need 2 of those. So multiply times 2.
2.6997.
All right,
Wait, I
so
don't know if I did this right. It says because I used the stove exponent. It says times 10 to the negative power 3.
exactly. All right, so now keep in mind, when it does that, that means it's a small number. You see where it says -3?
Mm-hmm.
Make 2 zeros. Okay?
Mm-hmm.
So it's always going to be 1 less. In this case, it says -3. Make 2 zeros and then start writing the number they gave you. Are you with me on that?
Yeah.
Okay. Now, it doesn't make a difference because you could still leave it in your calculator. That's because keep in mind, that's not the area I want, is it?
No.
So I need 1 minus this number. So just push 1 minus answer. How much is in the middle?
.9973.
Okay. Now, that's this right here. Now, did we answer the question?
No, not yet.
Okay, but we have what we need. We have the probability of a being in the middle, right?
Mm-hmm.
And we've got to do what of that probability? Multiply it times these number of trials. How many trials did we have?
800.
What's that times 800?
797.84.
And again, in this case, you can't have part of an observation. So what we're going to say is 798.
So this is like what we did last class. I haven't looked at the problems because like I had to finish
No,
up.
all I'm saying, because what happens, I think we did a problem just like this one, only it was 1 standard deviation above and 1 standard deviation below. And like I said, what's weird about it is this notation. It always throws people off.
Yeah.
Just keep in mind, they're giving you the z-scores. How we doing?
No, that sounds good. I was low-key worried because I was looking at the paper and I was so confused. Like, wait, what am I doing? But this clears up a lot of things.
All right, good. Now, don't forget, you still have those problems you got to do, in the end of the chapter, those test questions or whatever. There's 3 of them, right?
All right.
Make sure you work on those. But if you have any questions, just send me an email, shout, and we'll see if we can't figure it out.
All right.
All right? Anything else?
No, I think I'm good. But I'm gonna work on those problems today because.
Okay. All right, cool. All right. Well, let me know if you need any help.
No, those drawings, like they're really are helpful. Like just drawing a basic sketch, like yeah.
Yeah. Well, I really suggest that you do draw the pictures.
Yeah.
All right, man. I got to go. Have a good one. We'll talk to you tomorrow. Or I guess
Thank
Monday.
you.
All right?
Yeah. Thank you, Mr. Cross.
All right.